basically everything's in the atmosphere, just in really small amounts.
Bro, my life is like all day long. Sorry.
Go ahead.
Right now, it's a little bit
One out.
Can you just try it in, whatever, just try from the beginning maybe?
Yeah.
So a few separate announcements and stuff, and first of all, that warm-up.
Oh yeah, that warm-up.
So, a few different students talked to me at a few different times yesterday about their frustration with the grades and the exams. As you know, a lot of students are doing just fine, and that's great, but a lot of students are kind of used to doing really well and surprisingly not doing that well. And there's been a switch in Units 7 and 8. You may notice that the keys have gotten much more specific and the questions are much more specific, and if I had to whittle it all down to one single issue, I think that kids are saying a bunch of stuff that's accurate but not specific. Daisy and I were just looking at some questions that were appealed where, for example, the question would say, describe two methods of using biomass to make electricity, and kids are like, you can make electricity from biomass. And yes, students, that is accurate. But that does not really convince us that you know a whole lot about the content. Being specific is a big challenge to my students. And I did this thing yesterday where my kids were like, so come on, what do I have to know about Unit 9? And I'm like, I don't know, the last 4 weeks of class. And they're like, no, the specifics. And I was like, well, look at this. And I realized that almost every single question, literally, like of 69 study goals, or how many do 64? 67? How many? 64? Of 64 study goals, like 59 had a specific gas mentioned. So yeah, you got to know all the gases, for example.
Oh.
And I've been using the same analogy, so maybe if I already dropped this on you, I'm sorry to be repetitive, but don't get me out of my flow here. Imagine if you go to a mechanic and the mechanic's like, yes, it would appear that your engine has a problem. It's like, well, of course, that's why I came here. I was asking you. And they're right. They're just not being very specific. You would not go to a mechanic that goes, yes, there is something wrong with the engine. Because, of course, that's why you already knew that. It's not very convincing. It's not a diagnosis. If they're like, oh, yeah, you sucked a rodent into the timing belt, and that caused your third timing wheel to get off by 1 tooth. So now your exhaust valves are off by 1/64th of a second. You'd be like, yes, clear diagnostic. You named all the right parts and explained the relationship. I understand what you're saying. So likewise, what I think is happening to a lot of my kids, and I've seen it in a lot of your appeals, and I think that the scores kind of bear this out, is a lot of my kids have stayed conceptual in general, and they're just not answering specifically enough. And I'm not saying that you're wrong. You're just not right enough. That's what inspired today's warm-up. How many of you can name all of our gases from this unit? I know I can. Off the top of my head, too. Nitrogen gas, oxygen gas, argon, CO2 are the most common ones in the atmosphere. Greenhouse gases are like water vapor, CO2, methane, N2O, ozone, to a lesser degree CFCs. Oh, the primary air pollutants, ozone, SOx, NOx, carbon monoxide, VOCs. I'm forgetting something, but I'd probably remember if I wasn't going off the top of my head so fast. Oh, there you go. Somebody got it. The ozone-depleting substances like CFCs, HCFCs, halogens, sodium hexafluoride, carbon chloride, carbon tetrachloride. The Hofbrinkels, the diatomics, the Especially you got to know single chlorine, single bromine. Those are the most important ones for
The pros.
like it's kind of crappy of me to show off. Yes, I am the teacher, so I'm supposed to know these, and don't worry, I'm not very proud of it either. We can all agree I've had quite a bit of practice. But when students ask me what you're supposed to know, that's a really good place to start. You got to know all the gases, because then you can start to talk about how they all get along with each other. Okay. A few distractions before we do the nitty-gritty. Please look up. Today's the AP exam deadline. Are there any questions?
How much is the late fee?
Yeah. I think it's $10 per exam for a few days, and then it becomes $50 per exam for a few days after that. Oh, maybe. I'm sorry. Maybe 15. Next. Solar house model questions. Whoa, it's got a head rush. This is intense.
You're wiggling.
No way. If I want to deck, I want to deck hard. I think I'm okay. I just got the gnarliest head rush.
Low blood pressure.
Or high blood pressure?
Low. Is it low or high?
It was low.
I suffer from high blood pressure.
Oh, really?
Yeah.
Yeah, because that happens to me too, but yeah.
You have low blood pressure? Or are you like super chilled out? Do you like fall asleep really easy?
I mean, I don't know. It just happens to me if I like, stand up, see kind of like purplish, like hazes, stuff like
Yeah. I just got like neck of the boat
I
fever.
got told.
Alright, whatever. Moving on. If I pass out, you'll know why. No solar house model questions? Those will do Tuesday of the week we get back. And this time I mean it. Alright?
Do this for the 2 weeks. 2 weeks on for 2 weeks.
I've lost credibility. I'm the boy who cried wolf. Yeah, sure, it's dude. Okay, look. Right there where it says grade correction box, that's where you turn in any corrections from the grade that you all saw yesterday. Make sure that the period and name are clearly visible. A lot of kids will be like, no, I had the warm-up, and then they tear it out of their packet and they put it in there, and then you may not have written the name and period on the warm-up paper, and so it just goes to the no-name box and we'll never see it again. Yeah, bro?
Is lunch a good time for me to see my grade?
Well, I have a meeting with the aquaponics project, and they're planning a construction thing. So I'm pretty booked, but if you come in at like the first 3 minutes while we're all like distributing cheeseburgers, that might work. And you can see your grade on EDU.
I did already. I just want to see the actual questions.
The actual papers.
Yeah. Like the key and the short answers.
I might just get to the point where I'm like, good luck, I got to do this. But like if you're like right at the bell at the beginning of lunch, I'm sure it'll be fine. Does anybody know that they will be absent tomorrow from the exam? Would you be available to take it during period 0?
I'm leaving tonight, so no.
Cool, bro. Just checking. I'm going to be absent tomorrow as well, but I've lined up. Are you laughing at me? Oh, dude, it's tested. No way I'm going to be here. No way I'm going to be here.
Before spring break.
The day before spring break, and it's a special day for other reasons too. No way.
It's your birthday.
But so Cedar, you can't take tomorrow. 0 period. Anybody else?
You take it 6 period today.
Okay, so we'll see you Monday the 6th of April. But you, 0 period. Ryan Hughes already on there below. Did someone lose these glasses a few weeks ago? In my classroom. Blue box. Hey, look! You have a spring break optional extra credit reading quiz Monday at lunch when you get back. If somehow you didn't get the book, It's called Ecotopia. Remember, it's 5 points. Don't lose my books, please.
Still have copies of it?
Nope. We already talked about being specific. Please take out your study guide. We do the stars. Almost all of them get stars. Yeah.
What's the deal with study goal 59? It wasn't part of any of the assignments.
Oh, bro, might be. It was supposed to be. I just printed out the wrong page at the end. And it's like multiple stars. And it's like fascinating reading for nerds. Are you a nerd? You're a nerd. So, it's a good... Oh, no, dude. That's a good thing. It's a good thing. Ask Neil deGrasse Tyson. So, it's part of the reading package. And yes, you have to know. You have to get stars. Okay. On top of the little boxes of screws in the distant container. Another one? A assistant principal's office, attendant's office, business office.
Yeah.
No, but I'm pretty sure, like, I still read it. It's just like, here's a
Tell
whole
us you and
right in here. And I was just going by the reading packet.
This
It's not
one,
major, dude. You should probably
you
read
can
up.
take that to the business office and then ask for it. Should I wait?
I mean, I knew about it because I remember, like, 5 years ago watching it on a TV show.
And ask in a way that doesn't feel pressured. It's going to be very defensive today. We've already had fewer drinks, having a hard day. All right. Remember, first of all, that stars does not mean it'll be on the exam. It just means, like, you know, your notes better be good on this. And I think everybody knows by now that there's going to be a lot of stars in this unit because, as we've discussed, these are more detailed, nitty-gritty sort of topics. So just to like head off your complaints in advance, there's a bunch of stars. Like, a lot of study goals get done. Like, you know, there's just a lot of stuff that's going to come up later, a lot of stuff that kids get wrong, a lot of stuff that shows up on the AP test. Criteria pollutants, secondary pollutants, global dimming, 2 for the smogs, scrubbing, 1 for number 4. That's good. That's better. Just do it. Do the best. 1 for 6, 1 for 7, 1 for 11.
Bro.
In number 8. So yes, I'm going backwards now. I'm getting wobbly again. This is cool. In number 8, there was a key detail that the movie said wrong. Because remember that there's been a lot of scientific mystery back and forth, positive feedback, negative feedback, which way do clouds work, if there's extra water vapor, is that more heating, is that more cooling? Is it more greenhouse gas? Or is it more albedo?
Are you asking that?
Well, I just want to know. I'm not. Those were rhetorical questions. Thank you for checking. There was a lot of mystery. When the movie was made, people thought the opposite of accurate. So now, to clear up all confusion, in number 8, contrary to what the movie said, Lower clouds cause more greenhouse effect. Higher clouds cause more albedo.
What's albedo again?
Albedo is reflectivity shininess.
It seems cloudy.
Does everybody have that word, by the way? Albedo? A-L-B-E-D-O, shininess, reflectivity.
Is number 8 going to start?
I didn't give it a star because it's kind of like said wrong here, and you have an article later that says it right, but you might as well put a star on it, sure. Gabby Act.
Yeah, before we go on, number 4, do you remember this year? And then do that in your notes sometime to do it.
Oh, good. I have some time at the end for unfinished goals today. So 11 1 star, 12 1 star, 13 2 stars. 16-1, 17-2, 19-1, 22. Study goal 21 gets 3 stars. I warned you there's a bunch in a row. 22 gets a star. 23 gets a star. 24 gets 2 stars. In study goal number 25, did we correct the material in the book to give you the more updated estimate of climate change in the past few decades? Yes or no? Does everybody remember that it's been 1.8 degrees Fahrenheit, 0.9 degrees Celsius? You all have that? Just to be sure, if you were absent, your book, of course, being a few years old, is significantly outdated on this one issue. 27 gets 2 stars, 28 gets 3.
It's a lot of stars.
I know. 29 gets a star, 30 gets 2, 31 gets 3. I do love this book. You know, it's kind of stressful for a teacher. Like, if you have to buy a crap book, like, it makes it really hard to teach. And I actually got to pick out my book. I screened all the approved books and got to choose this one. And, like, I'm really glad that I did. Being an idiot, I never actually looked at the authors. And I was like, oh my god, this has so many Santa Barbara examples. What an awesome coincidence. And literally, I just knew them by the publisher at the time. And then when they arrived, I was like, oh yeah, Bucket and Keller. You know those guys. Because they're from UCSB. $35 gets a star, 37 gets a star, 39 gets 2. Is that not music to your ears? Like when all the papers move at once? Right, palm of my hand. 41 gets 2, 42 gets 3 stars. $43 1 star. $47 1 star. $55 gets 2, 56 gets 2. 59, which a lot of my students did not do, gets 2 stars. 59 was the last article. It's a really good one, so I added it to your reader. And on your version of the study guide, it wasn't added to the appropriate assignment. So I don't care where you write your notes for it, but 59 gets 2 stars. It's that article on geoengineering, which we also discussed as a warm-up.
We didn't discuss it.
One of those ones.
Geoengineering, you know, where like people intentionally affect our climate system, like the mirrors in space, or like the extra dust in the atmosphere, or like painting stuff white or fertilizing the ocean. Now we talk about it. 61 star. Study goal number 61 gets 2 stars, and the same for 62. Well, I need 5 minutes available of my undivided attention with no agenda. What would you have of me? Yes.
Can we go over 59?
Yeah, bro. Homeboy says, can we go over 59? And I say, yeah, bro.
Don't fall down on
Did you just say I should have subtitles? That would be so cool. Have like an English language translator right next to me.
From Jose.
In case you did not read the article, stop laughing, Hugo. In case you did not read the article, and of course, why would someone not read the article? But article number 59 is about geoengineering. Remember, that's when we intentionally manipulate our climate system. And everybody knows that we've already done one giant global experiment with the climate system. Sort of by accident, we added a whole bunch of greenhouse gases, CO2 and methane and others. As it turns out, it's pretty easy for humans to change the climate. Go figure. And we're not sure just exactly how long-lasting those changes will be, but it does appear that it's pretty attainable to make really significant change. And so right around now, people of right around your age are freaking out. Wow. Because like, holy crap, what are we going to do with like our current situation, and what sort of outcomes can we expect, and like how are we going to feed our children and stuff.
And the old people are like, ha.
Yeah, old people are voting for presidential candidates that straight up say there's no such thing as climate change. But young people know better than to discuss science as a belief issue. They also know that I can literally jump across these tables and punch Sarah Disraeli in the teeth with like 9 knuckles at once.
What about like 10?
So anyway, since we're all freaked out about our current climate experiment, there's like a whole field of climatology trying to figure out like how we could do another climate experiment and try to do the opposite, to do what's called global cooling, to change climate in an opposing sense. And basically there's only 2 options. You can either increase the albedo, so we bounce back more of the light that's turned into heat, or you can just block the Earth so that we get less light to make into heat.
So we should blow up the moon, right?
And so one of the hot ones is, dust to the moon.
No.
Too bad, too.
Well, we do
Yeah,
have-
some people have this childish attachment to orbital celestial bodies.
What about tides?
Why?
It's
The
like a
one
thing.
that I really like is to make an artificial supervolcano by burying a bunch of nukes in the desert and then getting a cloud of dust in the air.
Nuclear radioactive stuff.
Way that could turn out bad.
Yeah, what could possibly go wrong?
What could possibly go? We should tilt the earth so that it's windy. A bunch of nukes.
You know, actually, some people have wondered, would it be possible to change the Earth's orbit? Because we have seen that events on Earth do cause shifts in the Earth's orbit. As a matter of fact, relatively small events. Like big earthquakes, cause like wobbles.
Everyone walks in like one direction.
Everybody jumps up at once, yeah.
All running.
Ready, set, jump! Okay. Get up on your table and jump off. Look, like, your book has, your article has other options. I'm not going to read the whole article to you. What I think is actually the most interesting thing is, like, maybe it's kind of an esoteric question, but should we do that? Like, imagine if your doctor kind of like messes up and goes like, "Oh, sorry, just like punched a hole in your heart. Like, oh, I got to fix that." And you're like, "I'm dying." Have you lost all faith in your doctor? Like, do you have another option? That's like the modern world, I think. Like, oh dang, I just punched a hole in your climate system. I got this other idea, we blow up the moon. And like, do we want to go for that?
What's
like
the
the
organization that's trying to like voluntarily cause the human race to go extinct?
I don't know.
Oh, that's the.
Yeah, there's something like that.
Oh, yeah.
Suicide not.
Yeah, that was in The World Without Us.
It's like a group of people that just like, they all just like say like, none of us are gonna have children, and then they just die.
I mean, like,
They're going to say no there.
that is, I can see why you would mention that. I guess that's an option. But I don't think that's even remotely, like, if you thought it was crazy to blow up the moon, check out this other option. I have like a nagging feeling that actually sometime in your generation, this geoengineering thing is going to get pretty serious. So in the last couple of years, it's gone from like kooky whack jobs that get kicked out of conferences to like major global conferences to propose continuing unified international research
Alright, let's blow up the moon, guys.
on geoengineering. Some of these things seem to actually be picking up steam pretty fast. So there are already parts of the world where new buildings have to have either green roofs or like, you know, evaporative cooling roofs, or white paint on the roof, like that albedo increase. People have gone pretty far with the idea of fertilizing the ocean to soak up all the CO2. Like, there's, I mean, look, like, yeah, we messed up, but not doing anything doesn't seem like a very good idea. I mean, how many of you have that, like, sinking feeling about the climate situation? Like, and so I kind of wonder, like, how long can we go without trying something? And my guess is global dimming. But remember, you can't make an omelet without cracking some eggs. There will be losers, and probably they're not going to be rich people. You go? You sure? Yeah. Okay. Any other questions? Yes?
I'm confused still on the global dimming part about how like it's bad. You're saying we want it, but it's also bad.
Yeah. So, you know, if we make the planet dimmer, that would cool us down, right? Like a cloud of dust, like what cooled off the dinosaurs. So, yeah, you know, like dimming would cool us down, and that's a good way to counter all the heating. On the other hand, bringing up the spray bottle, just thought I should warn everybody. So, yeah, global dimming would cool us down. It would also make it harder to grow food and stuff.
I don't know if my conversation.
Sure, right on, good luck today. Yes.
Yeah, didn't that make the dinosaurs go extinct? So why would we even try that? Sort of that.
Because they were not trying to counter global warming, and we kind of have other parts of the equation.
Dinosaurs didn't do that voluntarily.
But, there's no point in hitting the brakes if you can just hit the gas. Okay, other vocab? Yeah, that's wisdom for you. Keep it in your pocket, bro. I'm right here. How can I help you? Yes, Gabby.
Can we go over number 30 again?
Number 30 again.
With the ozone.
Okay, but I just want to warn you that when I go over, I just go over. So what's your question?
Can you review the equations?
Review which equations?
Like the ozone equations you can't
Well, for sulfuric, it's basically just sulfuric acid. Do you need that? Salts in water makes sulfuric acid. For oxidant formation,
Yeah, we did.
so I'm combining two different ones, and so you can. So you had this one. Nitrogen monoxide.
No.
What's
You know that one?
Yeah, I just don't remember the concept of it.
Sure, and so I guess to get super conceptual, just to help you organize your thoughts, that would not be an adequate answer on a test because you're super conceptual. Nitrogen oxides and little bits of organic chemistry, like little hydrocarbons that are reactive, do a bunch of wacky stuff that results in these loose oxygens which stick loosely onto O2 to make ozone, or onto some kind of substrate with a loosely attached oxygen called PANS. Remember the peroxyacetyl nitrate? And so the general gist is when we've got NOx and volatile organics in our atmosphere. I screwed you up right there.
In their high atmosphere.
Actually, in our low atmosphere, that's not UVC, that's here. This is tropospheric. Smog happens where you are.
Is that just any ultraviolet light, or does it have to be a specific A, B, or C?
There probably is some specific, but I don't know. It's my understanding. Well, no. I'll bet you UVA is enough, and I'll bet you UVB and C would make it faster. Yeah?
What's PAN again?
So it stands for peroxyacetyl nitrates.
Yeah, but what is that?
It's anything that has this weird shape. And I don't think that it's necessary for you to memorize this. But Bailey, there is something I need to point out. It's called peroxyacetyl nitrates. It's anything with that oxygen string and a nitrate attached. And the deal is, when you attach a nitrate via an oxygen string, you get this part, which is a loosely attached oxygen atom. So that anytime that you have a loosely attached oxygen atom, you know that that's the freak out moment. Those are the oxidants. Like free radicals in your diet, for example. You go?
You go over UVA.
Sure. Ultraviolet light has a spectrum of energy levels, just like visible light has a spectrum of energy levels. UVA has very little energy. It's the chilled out one. So UVA, if you remember that bond distance sort of correlates to how likely it is you'll take away that energy. UVA can kind of scooch through low densities of matter like the atmosphere.
So it's dangerous.
So it's dangerous because it basically reaches us and gets into our living tissues pretty easily. It might not have a collision with Hugo's cells until it gets down to some living ones, and that can be problematic.
The UVB is less dangerous, right?
UVB, in a sense, breaks more bonds. So practically speaking, it's more likely to fizzle out in dead tissues. If it reaches you at all, it's also the exact size of the ozone molecule, so it tends to stop in the ozone layer.
UVC just constantly,
UVC would turn you into Hugo vapors,
but it doesn't reach.
but you'll never encounter it unless you're in outer space. Is that what you remember?
Yeah.
Does the inversion layer make the hot air go over, which like doesn't allow the city to become warmer than the air, making the pollution like trapped? Is that what the
Pretty darn close. But the inversion layer is hot air on top. So it doesn't make hot air. That's what you call it. Yeah.
Trapped in the marine layer.
But you've got the right concept. You know, like, you know that like steam comes off your soup and rises up because the heat source is down below it, and so things are rising from that heat source. So it generates this current, so that all that steam
the
rises.
pollution comes from over the mountain in LA?
In LA, the pollution's built in the city, but unlike your soup in that example, there's a layer of hotter air on top called the inverted layer, or the inversion. And so that inversion layer, it's like hot air cannot rise past hotter air because heat is pressure, so it's kind of holding down the pollution. So LA's produced pollution can't get higher.
And then what's the thing with the mountain? Like how you're talking about the cold air comes, or is it? The cold air comes in, the higher goes over the mountain.
Yeah, so the reason that it develops in Los Angeles, and this is just specific to one example, is because you've got a source of hot air while the city has trapped cool air. And you know, hot air will rise over those mountains, and that's how LA builds an inversion layer. Is Denver the Mile High City? So in Denver, they've got like the crazy Colorado Plateau making a bunch of hot air, and that whole city's filled in with cold, snowy caps, cold. So that's how they get their inversion layer. You need some source of hot air to trap some source of cold air. Yeah.
Kind of a different question. But
Sure.
will we need to turn in our like experiment results from the petri dishes? And
Nope.
No.
Nope, that was just an observational thing for us to have a conversation. There's such unreliable outcomes for that one that I was just hoping to have that day that we could talk about it, get a little visual on it. Yeah.
On 25, how could the effects of global warming be mitigated?
Oh, so those are the two, either raise albedo, lower light absorption.
Oh, okay.
What? Sure, yeah, that was just like a review of content from your book that may have been really clear for everyone. So, how does stuff come out of the atmosphere? Like, by what methods do things leave the atmosphere and come down to us? Your book had 4 options, which I'm sure you did in your homework: sedimentation, rainout, oxidation, and photodisassociation. And the only thing I was going to do in the class is say which of these is a chemical process and which of these is a physical one. So sedimentation is physical, that's just gravity, like heavy stuff falls to the earth. Rainout is physical in the sense that rain will capture dust and bring it down. But rainout is also chemical in the sense that water reacts with stuff, for example, oxides. Oxidation and photodisassociation, those are both chemical. Gabby, I didn't talk about it in class because I kind of thought a lot of kids already had that. Or,
I had it.
but is there anything I can do to be helpful? Okay.
What if, like, we mitigated global warming?
What?
If we mitigated global warming and it started getting cooler again, what would happen?
Ma'am, Is that a serious question?
Yeah.
It's gonna get cooler.
Cool. Yeah, like the weather pattern.
I don't know. They probably change again. Yeah,
Is there any way that global dimming can cause another ice age?
a lot of it would. Remember that most of our ice ages were part of what we call that astronomical theory of climate change. The basic nuts and bolts of shifting, the angle of the dangle, the Milankovitch cycles all lining up, you know? Global dimming can cause rapid cooling, and so the question is how much cooling is required for ice to accumulate. Ice ages are usually really long, like centuries at a very bare minimum. And you know, most global dimming is particulate in nature, so that would settle before then. So the meteor that killed the dinosaurs caused extreme dimming, extreme cooling, and no ice age because it wasn't long enough. So we just had 10 years of very, very cold, so cold that all the plants died, and then all the CO2 was left in the atmosphere, and it actually caused an extended period of global warming. So it just depends on the rates of change, whether or not it'll be an ice age.
But the moon is bigger than that asteroid, so could that much dust, if we actually blew up the moon, accidentally cause an ice age?
I'm not really clear on how... Oh, dude, A, I'm not qualified to make this prediction. B, I'm not really clear on where the dust would go from the moon. I don't think it's likely that it would enter our stratosphere in significant volume as dust. Yeah.
Two things, I guess. That whole moon thing, I don't know, my tutor was telling me about this like new theory you heard on like Radiolab or something that's like kind of being discussed now that when like the asteroid hit like, to the dinosaurs, like it shot up all these like particles, like just tons and tons of like particles and everything. Like as they came back down, they were like heating up and like burning whatever, and heated up the planet to like 500 degrees, like Kelvin or something like that, and vaporized everything, and that's why there's that like weird layer that like there's no dinosaurs past that, but like everything under like 10 feet of water or like 5 inches of soil survived or something. I don't know if you like heard.
I haven't heard any of those details,
Okay.
especially that temperature.
Alright, it's kind of
I do know that in the early history of Earth, we're talking like the very distant geologic past. In that first like 1.5 billion years, our planet went through these like space cold / all molten from meteor collisions. So like in the geological formation of the Earth, there was some pretty extreme asteroid impact, like concussion force, like splitting and re-slamming. I think the moon comes from the Earth. The moon was something that got smashed off in a meteor collision.
Yeah, I think it's like some like planet-sized body collided.
Something like that. Sure, yeah. I mean, I'll buy all that.
Yeah.
But it was my understanding that the dinosaur die-off.
It was that air column thing from the
It was what you might consider a relatively smaller asteroid. So that impact was still really significant. Remember that watermelon effect. But I don't really know.
yeah. But then the other part of that question was, what was that thing that caused that ice age to come like within like 10 years or whatever? Like didn't like an ice age like over like the course of 10 years and Earth was going to an ice age?
I don't know of that.
Okay.
I wouldn't doubt it. I just don't know
Okay,
details
so
of
like,
that.
Could you go over 17 or just like how it works, the ocean's conveyor belt? Just, I don't know.
Yeah, but without a diagram, I'm kind of
Yeah.
stuck. I mean, remember the convection current? Like hot and then cold, and so this one spreads, and so this one spreads. So basically, if you want to build up your set of facts, we have like our global circulation, those like 6 convection cells. Then, because you're spinning the planet underneath them, that makes like the trades and the westerlies in the temperate and tropical bands. because of that, you get these reliable wind patterns across the land masses. So pretty much you've got Indian Ocean upwelling and Alaska/Siberia North Pacific upwelling. And in another part of the ocean, you've got really, really windy conditions that cause super salty water that's also cold to sink. Right? So because you've got the sinking in the North Atlantic and the rising in those other two places, then you get the rest of the conveyor.
What's like stopping it?
Oh, because Greenland is melting. Greenland's a whole bunch of sea ice. And so as Greenland melts, we're adding fresh water, and fresh water floats. It's just water with nothing in it. Right? In terms of density, salt water is the same amount of water plus salt in it. Imagine you just get a salt shaker and you're adding it. That's just going to make... So the salt water usually sinks by adding